dear children, I hope all have finished the project work which I have given you last week, isn't it? And then you have come to certain conclusion. Now today we are going into the last part of the lesson, and there are a lot of activities that we have to do, and you have to observe and also write down your conclusions. Now, when you did the project last week, what were your findings? Many of you have sent me those things, and some of them are these which you can see here. So if you look into that, you can see that certain things which you took, isn't it? That is hibiscus, blue hibiscus paper, red hibiscus paper, beetroot, turmeric, all these things can be used to identify whether a substance is an acid or an alkali, isn't it? So there you saw that when a turmeric paper is dipped in an alkali or in soap water, it turns red in color. The beetroot also, when it is dipped in alkali, it turns pink in color, isn't it? Hibiscus, blue hibiscus paper, when it is dipped in an acid or vinegar, you can see that it turns red in color. So these are certain indicators what we can use, which we can use to find out whether a substance is an acid or an alkali. So substances, things, indicators are substances that help us to distinguish between an acid and an alkali. So I told you in the laboratories we don't use hibiscus paper or beetroot paper or turmeric paper. Instead we use many other indicators. Now you can see right in front of me there are many things, isn't it? You can see caustic soda is here, and you can see these two things. Now these two things are two indicators which are used in the laboratory. This is methyl orange and this is phenolphthalein solution. Methyl orange and phenolphthalein solution. Now we will see whether these indicators can be used for certain purposes to find out whether a given substance is an acid or an alkali. For the teacher is going to do a very small experiment here. For that I am taking, what is this? Sodium hydroxide or caustic soda. This is used for making soap also. So I am taking caustic soda pellet. Just one or two pellets I am putting it into the glass, and then I am making a solution. Pouring water into this, and I am allowing it to melt here. It will melt. By then I am taking a very easily available acid. Which is the easily available acid that we have? Vinegar. So teacher is taking vinegar also here, putting it into the cup. So we have vinegar and we have caustic soda solution. So two things are here. Okay. So this caustic soda, it takes time to melt here. Let it melt nicely. Now in this, we are going to use these two indicators. Okay. I hope you can see. So one is an alkali, one is an acid. We know caustic soda is an alkali and vinegar is an acid. So this is an acid, this is alkali. So we are going to see when I add phenol. First we are going to do the test with phenolphthalein solution. So this is an indicator. I am going to put just 2 drops of phenolphthalein into an acid. Both. First I put 2 drops in vinegar here. Okay. I put 2 drops here. We cannot see any change happening there. And I put 2 drops of phenolphthalein in alkali. So what happened here? The same solution. I put 2 drops in an alkali and 2 drops in an acid. So here when we put phenolphthalein, it did not change. The color did not change. But when I put phenolphthalein here, the color changed into purple or dark pink color. So what can we use this as? Yes, this indicator can be used to identify an alkali. So when we are doing experiments, we can use this phenolphthalein to identify whether it is an acid or an alkali, because we know all the laboratory things come colorless. So it is difficult for us to identify anything. So indicators here, phenolphthalein indicator can be used to find out whether it is an alkali. So in alkali, it will change color. Now the same experiment we will do using methyl orange. Okay, so I am closing and keeping phenolphthalein there. And then again I am taking 2 tumblers here. Okay, I am keeping this aside. And again I am pouring water into it. We will put just 1 or 2 pellets into that. Let it melt. Then again I am taking vinegar and pouring vinegar into the glass. And the same experiment we will do using I will take another thing because already phenolphthalein is there in that. So let it melt here. So the same experiment we are going to use another syringe and use methyl orange there and put 2 drops of methyl orange into here in this alkali. Here in the acid. Now here, see what happened here. In an alkali, it did not change color, but in an acid, the color changed to light orangish pink, isn't it? So here we can understand that methyl orange can be used to identify an acid. So phenolphthalein can be used to identify an alkali, and methyl orange can be used to identify an acid. So I hope you understood this. Now you have to write this in your science note. Okay. Now in your science textbook, you can see a table given there in the textbook here. Can you see a table given there? Yes. What is in that table there? The substance use is given. The color in acid is given. The color in alkali is given. What are we to do? Go through the table very carefully. Okay. Go through the table very carefully. After looking into the table, there are 2 questions given down there. What are these? What are the substances that can be used as indicators to identify acid? So look into that. Blue litmus paper, chili powder, red litmus paper, all these things are given. Look into the table, analyze the table nicely, find out which other things can be used as indicators to find out whether a substance is an acid. Then what are the indicators that can be used to identify an alkali? So 2 things. So which are the things that can be used, indicators which can be used to find out whether a substance is an acid, and which are the indicators that can be used to find out whether the substance is an alkali. So you have to draw this table in your notebook, analyze it nicely, then write down acid and alkali and write down the names of the indicators. So that is a work which you have to do on your own. Okay. Now down there in your textbook, you can see universal indicator. What is a universal indicator? Universal indicator is a mixture of different indicators depending on the strength of the acidic or alkaline nature of the solution. Universal indicators give different colors. So universal indicator is an indicator which can be used for all acid or an alkali. So the color changes. According to the color, we can compare the color chart which is already stuck on the bottle and find out whether the substance is an acid or an alkali. So universal indicators are there. That is not there with teacher. I cannot show you. So it is a substance which can be used in both acid and alkali, and according to the change of the color, the table will be there already given on the bottle. So keeping that table, we can compare the color and find out whether it is an acid or an alkali. So this is what we learned about indicators. So from the beginning of the lesson, we are learning about indicators. So I hope you understood this much. Now here we learned about the different indicators. Okay, we learned what is an acid and what is an alkali. Now we are going to see what will happen if an acid and an alkali mixes together. Have you ever thought, always when teacher is showing, I am showing acid separate and alkali separate, isn't it? Now we are going to see what will happen if an acid and an alkali mixes together. Is there any reaction that is taking place? For that there is a big procedure which is done in the laboratory. Now teachers not having all those things which are available in the laboratory, but with the available things I am going to do that. So for that we need an acid and an alkali, isn't it? So here I am taking hydrochloric, diluted hydrochloric acid. This is called 0.1% dilute. So for 1000 ml of water, 10 ml of acid is taken and mixed. So this is already done for me. Now the same way we have to make a solution of sodium hydroxide, that is caustic soda. So this is an alkali, this is an acid. So first we are going to make the solution of sodium. So it is for 1000 milliliters of water, we have to take 4 grams of sodium hydroxide. So because I cannot take like that, I cannot measure it, I am just taking 1 pellet of sodium hydroxide here, putting into a tumbler, and we have to take only 20 ml of water. So here I have a syringe, so we can measure 20 ml here. So this is 10 ml what teacher is putting into the glass. So now this is 10 more. So this is 20 ml of water. Now we have to melt this nicely. Okay. The caustic soda, that is 1 pellet of caustic soda, it has to melt nicely in this water. Okay. Now, which indicator can be used? We have to know what is happening, isn't it? So, that is like a magic. So, to know that what is happening here, we have to use an indicator. So, what indicator can we use here? Yes, we can use phenolphthalein indicator. Why are we using phenolphthalein indicator? Yes, because phenolphthalein indicator, when we put 2 drops here, the alkali will change its color, isn't it? So 2 drops of phenolphthalein teacher has put into that. So I'm keeping it separate. So now we got caustic soda solution and I have put phenolphthalein indicator into that. Okay. Now I am going to take the acid in the syringe because I am not having a pipette and burette here. I am just going to use a syringe here to take out hydrochloric acid. So in this hydrochloric acid also I am going to take 10 ml of diluted hydrochloric acid. Now we will see what is happening here because it is a very slow process. Teacher has to put only drop by drop into this and I have to keep swirling this mixture. Okay. So I am going to put drop. You have to observe what is happening here. So when I am adding the hydrochloric acid into the alkali, We have to see what is happening here. Okay. Now can you see some magic happened, isn't it? What happened? Yes, the color of the phenolphthalein is gone there. So here when an acid and alkali mixed in a particular quantity, what happened there? The solution is now neither acidic nor alkaline. So what happened to that solution? That solution is now not an acid, not an alkali. This process is called as neutralization. What is it called as? Neutralization. So what is neutralization? When an acid mixes with an alkali, it changes into salt and water. So now this is only salt water. Okay. So this process is called as neutralization. So what is this now? This is salt water. Okay. Salt water, or it is called as sodium chloride or common salt. Okay. The salt which we use for the curry. So when an acid and an alkali mixes together, it becomes salt water. So teacher told here that this solution is common salt. So this solution, when it neutralizes, neither will it be an alkali nor it will be an acid. So how can we test whether it is acid or alkaline property is there? Yes, we can test using a litmus paper. So here, if it is alkaline, then the litmus paper red will change into blue. And if it is acidic, then this litmus paper will change into red, isn't it? So that we can test using the litmus paper. So I am dipping it here. So here you can see that there is no color change in the red litmus paper. Now I am using the blue litmus. So in this also you can see that there is no color change in the litmus paper. So from this we can understand that this solution, that is we mixed an acid with an alkali and the neutralization has happened there, and then we found out that this is neither an acid nor an alkali. It is just salt and water. So this process is called as neutralization. Now in Kerala, isn't it, we can find out whether the soil in our land is acidic or alkaline using this method. So mainly in Kerala, the soil we find in Kerala is acidic. So what do? You have seen, isn't it, when people are putting manure for your compound, for the coconut trees and all that, the soil in Kerala is acidic. So what do? For the coconut palms, when they open during the rainy season, have you seen you putting quicklime for that chunnambu? Yes. Why is it there? Because of the acidic nature, it is not good for the trees. So we have to make the soil normal, neutral. So what do? If the soil is acidic in nature, we add alkali. And if the soil is alkaline in nature, we add an acid, okay, to the soil to make it neutral. So even if sometimes we get acidity in our stomach, isn't it? Haven't you seen acidity? If you eat something oily and all that too much, we get acidity in our stomach. So when you go to the doctor, what do they give? They give a suspension. What is there in that? There is something mixed with alkali. Okay, so when that goes inside the tablet or the syrup which is given to you, contains an alkali which goes into your stomach and it normalizes, it neutralizes. So your stomach pain or the acidity feeling inside your body neutralizes. So when something is more acidic or alkaline, if you want to make it neutral or normalize it, for an acid you have to give an alkali, for an alkali you have to give an acid, so that it will become normal and neutral. Now we are going into the last part of our lesson. Okay, here I have 2 glasses of water. You can see here, this is normal plain water from the tap I have taken, and this is I have mixed the water with the available soil in my compound. Now why did teacher take this? We are going to do one more test here. We are going to do one more test here. So we are going to test the pH of water and the soil in my compound and my house. So what is pH? This is a pH paper. Like the litmus paper, this is also an indicator. So this pH paper tells us whether soil or water or any substance is acidic or alkaline. Okay. So here on this pH paper, you can see numbers marked there, 1 to 7, and behind you can see 8 to 4, 8 to 13 is marked, 14 is marked there. So this is 1 to 7 here and 8. So if the pH is 1, 2, 1, 3, 5, 6 like that, if it goes, then the given substance is acidic, and if it is 7, the given substance is neutral. It is neither acidic nor alkaline, and if it is more than 7, then the given substance contains more of alkali. So if it is less than 7, the given substance contains more of acid, it is acidic, and if it is greater than 7, then the given substance is alkaline. Okay, so now we are going to test whether the water in my house is acidic or alkaline or neutral. So if it is 7, it will be neutral, and the soil in my compound, whether it is acidic or alkaline. Okay, so sometimes the given substance might not be correct pH 7. It can be according to the nature of the water or the resources available in our compound. It can be alkaline or acidic. Okay, so here I am going to test. So this is the pH paper. It is yellowish in color here. After testing, we have to compare it with the color chart. You can see the color chart here. So what have we to do? How do you know the pH of the water and soil? First you have to dip it in that substance. Then we have to compare it with the color chart which is given here. So here I am going to test my water. So we will keep it for just 1-2 minutes. Let the water in that drain, and then only we will be able to compare the color. Okay, now here we can see that when we keep it near the color chart, here we can see that it is slightly coming near 5 and 6. So it is not completely pH 7. The water is somewhere between 5 and 6 here you can see, isn't it? So this is how we can compare the pH. So that means the water in my well, that is slightly acidic in nature. Okay. So here we can see that somewhat it is between 5 and 6. So it is slightly acidic in nature. Now, in the same way, we have to test the soil also. Okay. So for that again, I am taking the pH paper and then I am putting into it. So here also we can see that color, isn't it? It is between 3 and 5. It is an orangish shade. So we told that the soil of Kerala is mostly acidic. So here also the color is coming between 3 and 5 and all that we can compare. So the soil is also acidic in nature. So this is how we can find out whether the soil and water. Now we have two. This is the soil and this is water. So somewhere this water is coming close to 6 and 7 here. Now when it is drying, it is coming. So it is slightly acidic, we can say. But here you can see it is orangish shade. So the soil is acidic. So this is how we find out whether water or soil, the pH of that. You would have heard the word pH, isn't it? The pH of water. So the pH of clear, normal water, clear water, pure water is always 7. The pH of pure water is always 7. So when you do it in a filter and things, when they do water treatment, they always see that the water after the treatment, when it comes through the treatment plant, they always see that the pH of the water is always 7 because that is good for us to drink. Okay. So I hope you have understood. Now, the acid and the alkalis can be used in different ways. The acid and alkalis are used in laboratory for different uses. In your textbook, you can see the table given there. Vinegar. What is the use of the acid vinegar? Yes, we use it to preserve food, isn't it? In pickle and other substances to preserve food. Then citric acid. That also it is used as a preservative in drinks. In drinks and food. Then nitric acid and sulfuric acid. It is used in chemical fertilizers and paint and dye. So in the paint and dye is what? The color which you give for the cloth and all that, that is called dye. So in paint and dye, nitric acid and sulfuric acid is used. Then plain sulfuric acid is used in automobile batteries. In the car battery, sulfuric acid is used. And tannic acid is used for the production of ink and leather. So for cleaning leather and all that, tannic acid. So these are the uses of acid. So please write down that table in your. Now, why is an alkali used? So, acids have many uses, we saw that. Now, what are the uses of an alkali? So, the alkali is used to manufacture soap. Then, manufacture of detergents and ceramic materials. Then, for industrial purposes and for purification of water. So, these are the two uses of acid and alkali. Okay. So, now we can see that soap is produced with the help of alkali. Okay. So, shall we make soap? Do you want to make soap at home? Yes, everybody wants to make, isn't it? So, the next procedure is soap making. So, teacher is going to make soap here. I will be showing you the procedure. You can do the same in your home. So, with that, we come to the end of our lesson. So the next is soap production, and after that we come to the end of the lesson, and there are let us assess questions. So children, please complete those activities. Thank you. Dear children, as we said, we are going to make soap at home. Okay, for that teacher has got certain things with me. This is a soap kit which you can get from the Shastra Parishad Center. So you will get a kit like this. All the needed things are there already there in the kit. So it is very easy for us to make. So one of the important contents of soap making is caustic soda or sodium hydroxide. Okay, for neutralization process we have taken sodium hydroxide. So the same sodium hydroxide flakes are needed. This is the main ingredient of soap. So this is sodium hydroxide flakes. Then after that we have talcum powder. We have got sodium silicate, then rosin powder and a little perfume and color which we have to give. Then we need 1 kg of coconut oil. So these are the things which is needed. So what are the things which are needed? Caustic soda, talcum powder, then sodium silicate and rosin. So these are the things which we need. So first the preparation what we are going to do. For that Angelina is here with me. She is going to do the preparation. So for that we need 350 ml of water. 350. So I have already measured and taken 350 ml of water. So into that water we are going to put this sodium hydroxide flakes. Now when we put this sodium hydroxide flakes or caustic soda into this, heat will be produced. So immediately we cannot make the soap. What are we to do? We have to mix it and keep it to cool for at least 3 to 4 hours. Only then we can do the next procedure. So I am going to put this caustic soda into the water, and we have to be very careful not to touch it onto our body. Okay, so mix it nicely, mix it. So if you touch here, you can see it is becoming hot. You touch here and see. Is it turning hot? Yes. So you can see the vapor also coming out. We are not heating it, but it's becoming hot here. So we are mixing it. It has to be mixed. You should not take any other aluminium vessel. We have to take only stainless steel vessel to do that. So this is an alkali, we know. This is a natural alkali. When you put in water, automatically heat is produced here. So I hope you can see this. Okay. So I am going on churning it and mixing it well. So this is the first procedure for soap making. Already there is a instruction paper given inside the kit. So if you are buying and doing it from home, you can look into the instruction kit and do it accordingly. So this sodium silicate, sodium hydroxide is mixed well. Now we have to put one more thing into that. We have to put one more thing. That is, it is called as filler A and filler B. Filler A is sodium silicate and filler B is talcum powder. So two things A and B are written there. So this filler A, we have to pour it into this and then keep it to cool. So we are going to put filler A into it. Mix it. Okay, so now both has mixed well together, caustic soda and filler A, that is sodium silicate. Okay, now this is mixed well nicely. Now it is very very hot here. We cannot even touch the vessel. It's very hot. So what are we to do? We have to leave it to cool for some time. So let it cool. After that we will do the next procedure. Dear children, yesterday we had done the procedure of soap making halfway, isn't it? So teacher mixed sodium hydroxide, that is caustic soda, and the sodium silicate into that, and kept it because it was not cool yesterday. So today after 24 hours we are continuing the work. So into this now I am going to mix 1 kg of coconut oil. So from that 1 kg, little bit of coconut oil I have taken here and heated it with the rosin. And the rosin is already there in the packet. You have to use this for this one, not the other any other type of soap. It doesn't matter if you don't use this. But I have heated coconut oil, rosin, and melted it and cooled and kept it. I have taken a plastic container here. I am going to put this coconut oil into this plastic container. So in this plastic container, I have poured coconut oil. You can see the coconut oil here in this. Into that, I am going to pour this mixture. Okay, this mixture I am going to pour it and mix it. I have mixed it. Now I am stirring it well. We have to mix it for at least 10 minutes. So I have to keep on mixing. Now we have mixed it for about 10 minutes. Now into this mixture, I am going to add filler B, or this is talcum powder. Okay, so this little I am adding, along with I am adding Angelina. So as she is adding, I am mixing it. Now when we mix it, this will become a very thick solution. So this mixture we have to stir for about 20 minutes. Okay, until it becomes thick. Now we have mixed it for some time. Now it's become a little bit thick consistency. Now into this we are going to add the essence. That is, we have to give color and smell to the soap, isn't it? So for that we give, this is now sandalwood. So I am going to pour the sandalwood essence into this mixture. So we will get sandalwood soap. Okay, so that is why I am putting this into this. And then we have done one more thing here. I have mixed rosin along with the coconut oil. That also teacher is going to mix it into this so that it will become thick and hard. So now we are going to mix the mixture nicely. Now already the color has come for the soap mixture. It is orange in color now, sandalwood, and nice sandalwood smell is also coming for the soap. Okay, so we will stir it for some more time. When you are mixing, be careful. You have to use either a stainless steel ladle, or you have to use a wooden thing. Okay, don't use aluminium vessels or anything else, because we know that it is an alkali, so it might react. So we have to be very careful. Either you can use a plastic, that is to mix sodium hydroxide. You should not use a plastic bucket because we know that it is boiling heat. So for that you have to use only a steel vessel, and then when you are mixing it with the other things, it is cool. So you can use a plastic bucket or a plastic container or a stainless steel vessel, and use a wooden stick or anything, because that is safe for you. And then when you are, if you are doing it at home, please wear a gloves, because teachers taking care not to touch it on my body. When you are doing, please see that you use a gloves when doing. Okay, now this is mixed well. Now this mixture we have to pour it into containers. We have to give shape for the soap, isn't it? So if you don't have containers, what you can do is, we can use paper cups like this. Okay, then it is easy to remove. If you are having steel containers or any other plastic containers, you have to line it with, coat it with coconut oil. If it is cup like this, then there is no need, because it will come out. And then if you have silicone mold like this, in that also you can pour it, so you will get different shapes according to your wish. Okay, now I am going to pour it into the container. Okay. With this quantity, we will get about 20 to 25 pieces of soap. Now here you can see that teacher has got about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 25 pieces of soap I have got here. So now this has to set for about 3 to 4 hours. After it is set and becomes hard, we can remove it out of the cup. After that, teacher will show you once we remove it out of the cup. After that, you have to use it only after 5 or 6 days, or it is better to use after 1 week, because the content of the sodium hydroxide has to go. If you use it before that, you might get itching. So you have to be very careful. You have to start using the soap only after 5 to 6 days. So this is the procedure of the soap. If you can buy the kit, buy, and with the help of your parents, try to do it at home. Thank you, children. Dear children, now here you can see the soap is set very well. It has become hard, and I am taking it out of the silicone mold. Okay, now you can see the soap. It's set now with good shape. Okay, so this is how the soap is produced, and we have to take it out from the mold like this and keep it like this for about 1 week, or you can keep it for more than 1 week, and then only we have to use it. So I hope everybody will try to do this at home. Please take the help of your parents. Try to do it. It is good to make our own products at home. So this is one of the uses of alkalis what we have learned. So thank you very much, children.